Hello everyone. Now we're gonna talk about the topic the singly linked list. A singly linked list is a linear data structure. Like an array, it is also the group of the similar data items. Just take an example of a train where linked list is very similar to train. It is like a train which consists of different compartments which are connected one after the another in a sequential manner. Where the first compartment is called as an engine and the last compartment is called as the last. The engine drives the train, and whereas the last compartment indicates the end of the train. Just to convert this train scenario in terms of the linked list, where each compartment can be considered in terms of the node, like this, where nodes are connected in a sequential manner with the help of the links. The first node is called as an head, and the last node is called as the last. The last node, the next part, holds the value as null because it is not connecting to any other node in the list. Whereas coming to the definition of the linked list, it is the sequence of the data items where each data item is called as a node and it is taking two parts. One is the data and another one is an address. Let's take an example of a linked list with four data values, the 10, 20, 30 and 40. The first node is called as a head and the last node is called as the last. The first node, suppose we have located at the address 1000. The second node is situated at the location 5000. This information we are storing at the address part of node 1. Similarly, the second node address is storing the address of third node. The third node address is storing the address of the fourth node. Whereas coming to the last node, as this is last, it is not connected to any other node further, hence it is taking the value as null. Let's see the declaration of a node in C language. This can be done with the help of the structure in C, like a struct followed by the structure name, which here I am taking it as a node. It is taking two parts. One is the data and another one is a pointer. A pointer is used to store the address, whereas a data is of type integer, which is holding the integer data value. But whereas a data can take any type of the data, that can be the integer, that can be the float, character, double, string, or whatever it may be. Coming to the singly linked list ADT, which is given as the group of elements, and these are the operations allowed on linked list, like create, it creates a linked list, insert, used to insert a new node into the linked list as a first node or last node or after a given node or before the given node. Whereas coming to the delete operation, which is used to remove the node from the linked list. That node can be the first node or last node or any desired node in between the first and last. We can search for the given element in the linked list with the help of the search operation, where the concat operation is used to combine the contents of two singly linked lists. Now we can display the contents of the linked list with the help of the traversal operation. This is also called as a display operation. Let's create three nodes. Just declare a node structure with the two parts as data and the pointer. This entire thing will refer with the name node, which is taking the data of type integer and a pointer next. And this node we are referring with the pointers first, second, and third. Now allocate memory individually for each and every node. Let's start allocating memory for node 1. Okay. With that node, I am referring with the name first. So for that, this kind of the memory allocation is allowed in C with the help of the malloc function, which takes the number of bytes as the parameter. Here you need to specify the number of bytes to be allocated at the runtime. So that number of bytes you need to compute with the help of the size of operator. Here I am using the size of operator to compute the size of the node structure, which is taking the two data values, that is the data and the pointer. So after computing the number of bytes, you pass those many number of bytes to the malloc function to be allocated during the runtime, and this will return the void pointer. Hence, you need to do the typecast. Then refer that memory allocation with the pointer first. That is about the node 1. Next, in a similar fashion, allocate memory for node 2 and refer it with the name second. Likewise, allocate memory for node 3 and refer that memory location with the name third. Now we have allocated memory for 3 nodes. Now try to insert the data into those 3 nodes. So let's see here into the first node. So here I can access to the first node only with the name of first, and this part is called as first arrow data, and this part is called as first arrow next. Now you need to assign a data value into the part of first arrow data. Hence you can use a statement like first arrow data equal to 10. Make the next part as null, hence that can be accessed as first arrow next equal to null. Similarly, assign data value into another node like second arrow data equal to 20 and make second arrow next as null. In a similar fashion, try to assign data value to node 3, third arrow data equal to 30 and third arrow next equal to null. Now we are ready with 3 nodes. We have allocated memory for 3 nodes, and as well as we have assigned data values into 3 nodes. The 3 nodes which are situated at 3 different locations. The first node at 1000, second node at 2000 and third node at 3000. Now you need to make them in a sequence as attach second node next to 10 and attach third node next to second, like by using these 2 statements. So with this, we can attach second node to first node, and this statement is used to attach the third node to second node. Just see this. The first node, which is holding the address of the second node, then a link will establish between first and second. Similarly, the second node holding the address of the third node, then a link between the second and third. In this way, we can arrange all 3 nodes in a sequence. Let's look into the generalized code where we can create a more than 1 node into the linked list. There's the same structure, the node structure, which is taking 2 parts, the data and the pointer. Now you should be familiar with some terminology, the linked list is some terminology, that is a head. The head is a pointer which always points to first node in the linked list, where last is a pointer which always points to last node in the linked list. Initially, you need to make head as null. Initialize head pointer with null. That indicates the list is empty. Now, one more pointer is very important, that is the temp pointer, which is used to move in between the nodes. That means we should not move the head node from the first. You should not move the last pointer from the last. The only pointer which can be moved in between the first, the head and the last is, that is the temporary pointer. Whenever you are allocating memory for the new node, that can be done with the help of n. N is nothing but the current node or the new node. Okay, so like just now what we discussed, the allocation and the insertion of data, in a similar way, just allocate memory by using the malloc, and whenever you are allocating memory, that address should be referred with n. Okay, then insert the data into the data part of n as n arrow data. Okay, and then make the next part as null. Now you see this. Now this is the way of creating a new node, allocating memory and insert the data value into the new node and make the next part as null. Now you see here, take the if statement. Here I am checking whether head is null. So this becomes true when list is empty. That means initially whenever you are trying to insert the data for the first time, then head is null. In that situation, that means if a head is null, then whatever new data you are inserting into the linked list, that node will become the head node and that node will become the last node. So that's why I have written these two statements, head equal to null and last equal to head equal to n and last equal to n. That is nothing but the current node becomes the head node and the current node itself is the last node. Now, for the next insertions, that means whenever you are trying to insert the next node, again you need to repeat the procedure. The previous procedure like allocate memory and refer that memory with n and insert the data value into the data part and make the next part as null. Likewise, I have allocated memory for the node structure that I am referring with n, and the data part I have initialized with 20 and I am making the next part as null. Now this is my second node. This is my current node and that is my second node. In the linked list already I am ready with another node, one node. The linked list is having the one node that is 10, which I am referring with the name head and last. That is coming from this point. Yes, now we are going to execute the else part. Here head is not null because head is holding some data value. It is assigned some address that is 1000. Now head is 1000. So this is called as head arrow data and this is called as head arrow next. Whereas the same address we are referring with another name that is last. Hence this is called as last arrow data and this 2000 is called as last arrow next. Now what you need to do is we are ready with the current node that is 20. So this you need to attach at the end of, that means we need to attach this next to 10. Okay, now what we have to do is here the head, we know the meaning of a head. We should not move the head pointer from the first node. So the only alternative is you can move the last pointer, because whenever you insert this 20 into the linked list, this will become the last node. Then this should be referred by which name? By the last name. Hence what I am doing is I am storing the address of second node as the next part of the first node. Okay, so this part I can refer with the name last arrow next. Last arrow next should store the value 2000. That 2000 I can refer with the name n. Hence I can use the statement like last arrow next equal to n. So after executing that statement, a link will establish between 10 and 20. Now, my next task is you need to make this node as the last node. So in that case, what I can do is just by giving the assignment statement like last equal to n, then I can move the last from this position to this position. Okay, so let's discuss this scenario once again by taking the third node. Again, allocate memory for node 3. Okay, and then refer that third node with the name n. Insert the data value as n arrow data equal to 30 and make the next part as null. Now we are ready with third node. Now you need to establish a link between these two. That how I can do, what is the name of this part? This part is this entire node I am referring with the name last. Yes, so this part is called as last arrow data and whereas this part is called as last arrow next. Now what I am doing is in place of null I need to write the value as 3000. The name of 3000 is n. Then what I can do, like last arrow next equal to n. Okay, so this null will replace with 3000 like this. A link will establish between these two. Now, after attaching 30 at the end of 20, then you need to make this last node as the last point. That how can I do? Last equal to m. Yes, so this is the procedure to create a singly linked list. Let's discuss the traversal operation. Where Take an example linked list of 4 nodes as 10, 20, 30, 40. As we know that the first node always refer with the name head, and this name, the name of 10 is head arrow data, and the name of this part is head arrow next. As we should not move the head pointer, and in this procedure you need to display the contents of each and every node. So in that situation, what I'll do is I'll refer the first node with temp, like temp equal to head. Now the head is becoming temp. Now till you reach end of the list, so that I am repeating some statements. Hence I have written, I have enclosed these two statements within a loop. While temp is not equal to null, here what I am doing is first temp is pointing to head. Now it is printing temp arrow data as 10. After that, I am moving temp to next node. What is next? Next is 5000. Hence, temp is moving from 1000 to 5000. Now, at 5000, what is temp arrow data? That is 20. Now, after printing 20, what I am doing? Again, I am repeating the statement temp equal to temp arrow next. So, this temp is moving to 2000. Now temp is pointing to the location 2000. Again, here it is printing temp arrow data. What is temp arrow data? 30. Now after printing 30, again I am moving temp to temp arrow next. What is temp arrow next? That is 2500. Now moving temp to from 2000 to 2500. Now here, what is temp arrow data? 40. That we are printing as 40. Now moving temp to next. So what is next of temp arrow next? That is null. So this we are repeating until temp is not equal to null. Now here if you see, it is printing the contents of linked list starting from 10, 20, 30 and 40. So like this, the display operation will function. Let's code for the creation and display operations of singly linked list in CodeBlocks platform. Take a new file, an empty file. Just save it with some meaningful name. I'm taking singly linked list create.c. Just give description about the program. C program to create singly linked list of integers. Now include required header files. One is the stdio.h. Another one, as we are using malloc, you need to include stdlib.h. Now declare struct node, which is taking two parts, the data. As we are creating the singly linked list of integers, the data must be of type integer. Struct node star next, the next pointer is where this node structure is used by three variables. One is the head, which I am initializing with the null, which indicates the empty list. Next, a last pointer to refer to last node. In between, to move, we'll use temporary pointer, and the new node is always an end. Now, take functions. Here I am performing the create operation, and then the another one is the display or the traversal operation. Let's write the main function. Just here I am writing the menu driven function, hence menu driven program, hence I am using a choice variable as a ch. Just write printf. The one I am calling create, for two I am calling display. Just so write a do while where repeatedly will ask for choice. Enter choice and read the choice variable. Then pass choice variable to switch, to invoke cases. Case 1, first I am invoking create, give break, and whereas case 2 is for display and then a break. This you take till choice is less than or equal to 2, as we are having only 2 choices. Now let's implement functions. First starts with void create. Now here the first and most important step in creating this include linked list is allocation of memory. That is struct node star using malloc of use size of struct node. Now printf enter data, insert data into the data part of n. So that is scanf %rt ampersand in arrow data. And then make next part as null, n arrow next equal to null. For the first insertion, you need to check whether list is empty by writing head equal to null. If head is null, then head becomes n and the same n will become last. Now head and last both are pointing to first node. For the next insertions, write else part. Move the last pointer, last or next equal to n. Just establish a link between the last node and the new node, and then move last pointer to m, last equal to m. That's all with create. Write display. Now take the temp. It is referring to head. That means it is pointing to first node. Now repeatedly you need to perform some operations like while temp is not equal to null till you reach end of the list. What you need to do, print each node data, that is %t, which is temp arrow data. After printing node data, move temp to next node, temp equal to temp arrow next. That's it with create and display operations. Let's build and run this code. Just here give the choice as 1. Now insert the data value 10. Now give choice as 1 again. Just take node 2 as data 20. Choice as 1 again. Node 3 as data 30. Choice as 1 again. Node 4 as data 40. Again choice 1. Node 5 as data 50. Now give the choice as a 2. It displays all data values, the entire linked list as 10, 20, 30, 40 and 50.